have, we work on the X3 because X3 is the median. So we want to take away this median from the consideration. Yeah. The reason we can do that because we know the right position of this median in the final sorted array. We know its position. If we know its position, then we can always put it in the right position without any comparison. Okay, yeah. So here we use this simple observation. Yeah. Observation or property. Yeah. Okay, yeah, we use this observation. Yeah. Since the final position of X3 is known. Okay, yeah. After we sort these unknown, yeah, we treat these elements. All right, so Shirley join us. Good. All right. After we sort these 4 unknown elements. Now, here, unknown, I mean their position, their final positions are unknown. Okay, their final positions are unknown. After we sort these 4 elements, we can put X3 back in without any comparison. All right, here, this is one view, all right? This is only one view for us to look at this question. Yeah, why I emphasize this one? Because you can solve this problem using a different view. Yeah. Yeah. This is just one of the views you can use to solve this problem. Yeah. You may have other views. Yeah. So it's very easy. So you have different views with different solutions. Yeah. So here I just give you one relatively simple view, I feel. Yeah. All right. So with this observation, yeah, then our question is reduced. Yeah. This question reduced to the 4-element sorting question. All right, yeah. So next, I explain this question. Yeah, 4-element sorting. Yeah, it is in my original plan. I haven't explained. Yeah, so here at this point, I explain this 4-element sorting question. Yeah. All right, so next slide, let me Let's, oh, yeah, chat message. Let me see. Maria, you cannot hear? Okay, all right, no problem. All right, so let's continue. Yeah, no problem. All right, let's go. Yeah, so here, the question, yeah, I just write it simple, 4-element sorting. Okay, 4-element sorting. Yeah. Here, you know, we can treat this as an independent question. Okay, yeah, nothing to, so when I write the presentation, it's nothing to do with our homework question. Yeah. The reason I say that because in this way, I just use x1, x2, x3, x4. All right, yeah. So I do not use our old notation x1, x2, x4, x5. Yeah. So this is a, you know, itself is one question. Yeah. All right. So here, when I do it, yeah, although there are many different ways, yeah, I try to find a way that you can understand easily. Okay. Yeah. Because there is a possible way. Some students, they do comparisons here, there, without organized way. So very messy. Yeah. It's hard to keep track of the comparisons. Here, I want to give you a solution, and you can very easy to keep track of all the comparisons. Yeah. Just by our insertion, by the insertion sort. We learned the insertion sort. Sorry, insertion sort. Yeah. Here, I will use the insertion sort, but with small modification. Yeah, we need to do some modification. Yeah, with some modification. All right. So let's do step by step. Yeah. Insertion sort. Yeah. First, sort subarray, right? Yeah. First two elements subarray, x1, x2 in one comparison. Yeah. We just use one comparison. So we can get this array sorted. Yeah. So that is, yeah, let's say x1 here, x2 here. Okay, yeah. Because we just, assume after one comparison, it is ordered. Yeah. Step 2, all right. Sort, this time, 3-element array, but we insert x3 into a sorted array with 2 more comparisons. Okay, yeah. By insertion, yeah. Because we know x1, x2, then x3 here. We just do one comparison. Yeah, yeah. our standard insertion, we compare with x2 first, okay? Then x1 if necessary, but we consider the worst case. Yeah. We always, here. When I ask you to sort some array, given array, you always work on the worst case. Do not work on the best case. Because if you work on the best case, you have not solved the problem. Still, there are some other cases you cannot handle, but if you can handle the worst case, that means you can handle all the cases. The worst case is if you can, find a solution for the worst case, the worst case, it can cover all the cases. Yeah. That means you complete the whole solution. Yeah. Here, we consider the worst case. So that means we need two more comparisons. One here, another one there. So total two more. Yeah, so that's the step number 2. Step number 3, sort this time the whole array, x1, x2, x3, but we know the first 3 elements already in order, and we need to join the last element 4 with an ordered subarray, x1, x2, x3. Yeah. Here, for convenience, we assume they are in this order. Okay? Yeah. I mean, after 3 comparisons, we make the first 3 elements in order. All right? Yeah. Okay. And last element x4. Now we need to do that modification. Yeah. Here we should not use our standard insertion operation. If you use the standard insertion operation, then you cannot get the best solution. Here we want to get the best solution. All right? Yeah. So for the best, what kind of modification we will use here? Yeah. Use the binary search idea. You know the binary search, right? Binary search idea here. Yeah. All right. So when you do comparison, x4 with elements in this ordered array. Yeah, because this is an ordered array on the, so here, ordered array. We know a faster way is doing the binary search. So that means we compare x4 with x2 first. Yeah. Here is a modification. With the one in the middle, median, x2 first. Yeah. So this is our first comparison. Okay. Yeah. After that, then you only need one more comparison. Okay. Either with x1 or with x3. Yeah. But one of the 2 cases. You do not need to compare with both, right? Yeah. Already ordered. Okay. Yeah. So in this way, the binary search type insertion. Still insertion, but we can do a little better. Yeah. Because if you use the standard insertion, you need 3 comparisons for the worst case. Yeah, here. Okay. If you use standard insertion, then you need 3 more comparisons. That's not the best solution, but if binary, way, because we do not have a special name for it, right? Yeah. Then only 2 comparisons. For the insertion. Right? Yeah. So after these 3 steps, then we calculate the total number of comparison. Yeah. Step 1, 1 comparison. Step 2, 2 comparison. 2 more. Step 3, another 2 more comparisons. So total 5 number of comparisons. That's the best solution. So this is the best solution. The solution. Okay. Sorting 4-element array in this way, you can get the best solution. Because here we use the insertion idea, so then it's very easy to keep track of all the comparisons. Yeah. Some other different ways, some students, because you just pick a random elements to do comparison. If that, in that kind of method, it is not easy to keep track of all your comparisons for the worst case. Okay, yeah, all right. So that's the so we finish this question. Then you can use the result of this question. Then you can find the answer of our homework question number 21 easily. Okay, yeah. All right, yeah. So we complete that one. Any questions so far? Yeah. In understanding? Yeah. If no, I move to the next question. Yeah. All right. Next question. Number 22. Given a 247 element array, what is the minimum number of comparisons that you need to find an element that is among the top 8 in the sense of values? Yeah. So top 8. So not position. Position, sorting position. Right. If you sort in ascending order, then the highest 8 values. Yeah. Top 8. Yeah. All right. So that's this question. And here, this number, actually, this number is not important. So we can treat it as just an n value. Yeah. N equals this number. Yeah. That means if you change n to different number, your solution pretty much the same. Yeah. All right. Same, what I mean, the method you use pretty much the same. Yeah. All right. Now, to solve this one, I like to point out a closely related question to this one to help you find a solution. Otherwise, if you do not use a closely related question, we studied in module 1, actually in here in our module 1 part C, the question, finding the minimum of an array. This is closely related question. So you need to recall, you need to be familiar with the details of this finding the minimum question. And you use the similar thinking way and extend it. Definitely, you need to do some extension and you can find a solution. But still, you need to do the lot of analysis and the thinking work here. All right, so here, let me give you the, connection between these two questions. All right. Here, let me write a general version. General version here. All right. Okay. So that is given. And n element array. Okay. What is the minimum number of comparisons? All right, to find an element among, I just, skip some less important words among the top K, here. I use another general number K, N and K. Replace concrete numbers to variables. Because if you use this general version, then this question and the finding the minimum question, they belong to the same general version. Because when K equals 1, finding the minimum, or you can consider finding the maximum, right? So K equal to 1, so that's the finding the maximum. Because the value is top 1. You find an element among the top 1. So the solution, we did it in module 1 part C. That is the K equals to 1 version case. But here in this question, our K equals 8. Okay? You just change the number from 1 to 8. The question type is exactly the same. That means these two questions are closely related. If closely related, why not? We just borrow the similar solution from that old one. All right, yeah, here, let me shed a little more light. Yeah, here, all right. Elimination method. Use elimination method or elimination view. Yeah. So we understand this question by this elimination view. Yeah. All right. So when we start, okay, finding the top one element, that is the maximum case. Okay. That means we use comparisons to eliminate n minus 1 elements. So this is the interpretation of the elimination view in our old question, finding the minimum or maximum, yeah, because it's equivalent, yeah, minimum, maximum, yeah. All right. Eliminate n minus 1 elements. All right, yeah. So then, moving to this question. Yeah. This time, finding a top 8 element. Okay, yeah. That means we need to use comparisons to eliminate. All right. Eliminate. Because remaining, think about this. Survival, right? After elimination, the survival elements, there are 8 elements survival after elimination. Okay, yeah. So by using the comparison, we need to eliminate n minus 8 elements. How about that? Because if we can eliminate n minus 8 elements, then because that means all the remaining elements are not all, we should not say this, all the remaining elements. Then, because here, this is the critical step. This step is the critical step. Okay, all right. Yeah. Yeah, so let me use a few more words too. So here, I hope you understand this, the meaning of the elimination. Beats greater than, okay? All right, so eliminate, yeah, let me, right here. Yeah. Eliminate. Yeah. The winner, yeah. The winner is greater than those losers. How about that? That's what we mean elimination. Yeah, yeah. But you use comparisons to determine winner and loser. Okay, by comparisons. How do you determine winners and losers? By comparisons. Okay, comparison. You have winner and loser. Okay, yeah. So the winner. So you have a winner, right? Yeah. So you use a winner element. The element, yeah. That is a winner. That one beats n minus 8 elements. Okay. And you get an element that beats 1 minus 8 elements by comparisons. Yeah. If you can, then the conclusion, we say the conclusion, the winner is among the top 8. How about that? The winner is among top 8. Think about that. Yeah. Yeah. I should not say the remaining 8 elements. Yeah, that could be wrong. All right. Yeah. I just say the winner. How about that? The winner is among the top 8. But the remaining elements, we cannot guarantee, the remaining elements also among top 8. No. Yeah. Yeah. So I should be very careful. So when I write the conclusion here. Okay. All right. Any question for this one? Yeah. Think about that. Yeah. If you understand the logic here, then you can find the answer easily. Yeah. But you really need to understand the logic. Yeah. Comprehension, very important here, with respect to the elimination method. Yeah. So that view is very important. Yeah. Okay. Yeah. All right. So next question. Question number 23. Given an array with n greater than 3 elements, you can apply one swap operation on arbitrary 2 of the elements. What is the maximum number of inversions that can be reduced by one swap operation? Yeah. Here, this question is a relatively hard one. Okay. Yeah. Relatively hard one. Yeah. And it relies on a lot of analysis. Yeah. it relies on, strong analysis. Okay, yeah. All right, yeah. Here, I like to do analysis on the most important property here. Yeah, so here, the property. Let me look at one important property. And then you try to use this property to answer this question. It's a hard question. This one of the hardest questions in this assignment. All right. So let's consider we have array with n elements. A1, A2, okay, yeah, dot, 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 all right. And here, let's say element AI, dot, 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 AJ, dot, 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 okay, all right. So the last element, AN, yeah, AN. Here, when we do analysis, so we like to do some, accurate analysis. Accurate analysis. All right. So here we consider the swap operation between these two. That's very general, right? So it is a general swap operation. General swap operation. Okay? Yeah. And now think about what is the impact of this swap operation on the total number of inversions. We need to study this. If we do this one swap operation, what is the change on the number of inversions after this swap? Okay, so we study this. So here we study. Let me write here. Study. The change of the number of inversions after this swap. Okay, yeah. That's what we need to study. Okay, do our analysis. All right. Yes. Yeah. All right. So let me write another line segment. Because here I need to mark a few points clearly here. So AI here, AJ here. These 2 points. We need to do swap operation. All right. And you can see these 2 positions divide the original array into 3 segments. 3 segments. In this segment, there are I minus 1 elements, right? There are I minus 1 elements. All right. In this segment, how many? There are M minus J elements, right? Okay, then between these two elements, how many? How many elements between these two? Excluding AIAJ. Okay, all right. How about J minus I minus 1? How about that? J minus I. How about this number? This many elements. Can you see that? Minus 1. Yeah. Why? To verify. Yeah. If you are not convinced, let us verify it a little bit. All right, so we add these numbers. Yeah, the first segment, this number, we know it is correct, right? Yeah, because it's easy, the first. The last segment, we know n minus j, also correct, right? Yeah, all right. Then the middle segment, so we are not quite sure the number of elements in the middle line, middle segment. Yeah, let's do verification. This number, yeah, add these elements plus 2, that should be n, right? The total number of elements. Yeah, so let's check. Okay, yeah, I minus I cancellation, j minus j cancellation, right? Minus 1, add 2, 0. So that's n. Left hand side n, right hand side n. So it is correct. Okay. So after this verification, then we are convinced. Yeah. So the middle segment between AIAJ, excluding these two elements, yeah, we have this many. Yeah. Yeah. Because counting these numbers is important. All right. Now, when you do swap, think about what are those inversions that could change? Yeah, inversion, because when we do swap, some of the inversions could change. All right, yeah, yeah. And here you only change position AIAJ. What are those inversions that could change? Okay, all right. Yeah, here, let me write a number. Segment 1, segment 2, segment 3. Okay, yeah. All right. So you can see, yeah. Look at that. Look at this. Look at this. Yeah, so yeah, so that's the reason it is hard. Yeah. All right. So now we consider, yeah. So here we consider X and Y. Okay. Yeah. Arbitrary two elements. Yeah. We consider. Okay. All right. Yeah. Okay. Yeah. 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 All right. Yeah. Yeah. Here. Yeah. Yeah. Because this is a little hard. Yeah. Yeah. Let me delay this question. Yeah. Because I do not have much time. Yeah. Let me delay this question. Let me talk about next two questions first. So this one, you know, I may I may add it later. Yeah. So today, let me talk about remaining two will be easier than this one. Yeah. All right. This question, number 24, 6 element, and we know x1 is different from the minimum. Okay. And x6 is different from the maximum. Okay. All right. Our goal, we need to find some element, yeah, let's say x, among the array such that x not equal to min and x not equal to max. All right, yeah, the goal. And this question closely related to one of our questions in the quiz. Can you remember? Yeah. Question 9 of quiz 1 or quiz 2? Quiz 1, right? Yeah. Question 9 of quiz 1. Yeah, I remember. So look at quiz 1, question 9. Okay? Yeah. In that one, although we use 1,000 elements, that answer is we can use 3 comparisons. To find an element. Yeah. Different from min, different from max, among 1,000 elements. Yeah. This large number, we just need 3 comparisons to find, such element. Yeah. And here we reduce from 1,000 to 6. Okay. Reduce from 1,000 here, 6. That means we can, we have a solution. Yeah. The solution may not be the best. We have a solution with 3 comparisons already. Yeah. Just the same way we did in this quiz question. Okay? Yeah. But because in that old question, where we do not have the information x1 not the minimum, x6 not the max. We do not have that information. And this question, we have more information. So then our solution should be better than this 3 comparison. We are looking for a better solution. Yeah. If not better, then we just take old solution, right? Yeah. The better it means we should use a fewer number of comparisons. Okay. For that reason, for that reason, here we target 2 comparisons. So our goal here, we want to use 2 comparisons to get a solution. Okay, all right. Yeah. Next question, how to do it? Yeah. How to do it? Yeah. You need to take advantage of the given info because this given info is valuable here. Okay, yeah. You should not throw it away. So what is the given info? That means the minimum already less than x1 and x6 already less than the max. Without comparison, you already have these two inequalities. Yeah. Next, you just need to complete the remaining part. Yeah, because the given information only gives you the partial information you need for the solution. You need complete the remaining part by two more comparisons. Okay, yeah. Yeah. So you have to, when you use two more comparisons, you have to use them in a wise way, smart way. Yeah. Do not waste. Yeah. Those two comparisons are very precious. Do not waste them. All right. Yeah. Here, for example, because for the first comparison, then we have some freedom, right? Yeah. Because the second comparison is very important. But the first comparison, yeah, we have some room. Yeah. So the first comparison, yeah. So we can pick x2, right? Yeah. We can pick x2. Yeah. x2, 3, 4, 5. Yeah. Any one of the four, because we have no information for these four elements. Yeah. Here we just pick x2. Yeah. After we pick x2, we can compare it with the special element x1 or x6. Yeah, just compare with one of the two. Yeah. Okay. Yeah. So first compare. Yeah. Here, let's say we compare with x1. Okay. Yeah. The first comparison, compare it with x1. So you have two cases, right? The first case, x2 less than x1. Second case, x2 greater than x1. Yeah. Because here I assume distinct elements. So do not consider the equal case. Yeah. x2, oh, you only have these two cases. No more than these two. Okay, all right. So which one is easier for us? Easier for us to get solution. Yeah. Yeah. Look at that. If x2 greater than x1, can we get a solution? Because combining with that one, you will get a minimum less than x1, right? But you also get x1 less than x2. Can you get a solution after that? Right? Yeah. If you get a solution, that means only one comparison you can get a solution. You do not need two. You just need one. Okay? Yeah. But in this case, definitely x1 is, you cannot say x1 is solid because x1 greater than x2 greater than minimum. But you do not know if x1 is less than the maximum, right? Yeah. So this one, you need the second comparison. Yeah. And the second comparison, you should use it in a smart way. Okay? Yeah. But when you second comparison, you can assume x2 is less than x1. So this information is useful. Okay? Yeah. So you take it, you put it aside, then yeah, you try to design your second comparison. Your second comparison is very important, very precious. Do not waste it. Okay, all right. But here I do not tell you how to do the second comparison because that's critical. That's the same thing as telling you the answer. And I do not want to tell you the answer here. Yeah, you need to find it by yourself. Okay, but I tell you one important guideline. One important guideline. Okay, when you do the second comparison. Okay, yeah. All right. So the guideline for second comparison. Okay. Do not touch any of these three elements, x3, x4, x5. Do not touch any of these three elements. Yeah. The reason is simple. Yeah. I hope I have more space here. The reason is very simple. Because those unknown elements, if you touch, you waste your precious last comparison easily. Yeah. You don't want to waste it. Yeah. So you want to spend your precious last comparison on these three elements with known information. Yeah. Yeah. So spend your last on, yeah, I cannot write too many words, on x1, x2, x6. Yeah. Then one comparison, you can get enough information for the solution. But if you touch some unknown element, yeah, x3, x4, x5, any of the three completely unknown. So one comparison is not enough to know that unknown element well. Okay? Yeah. You just waste that precious one comparison. Do not touch any of them. You know, spend on that last chance on known elements. Known elements. That's the guideline. How to, then you need to make it. Okay? Yeah. So with this information, then you need to complete the remaining part. Yeah. That should not be far away. Yeah. Yeah. You should be able to make it with some effort. Okay? All right. That's question number 24. Yeah. So for the last one, yeah. Last one, actually it's not too hard. Okay? Yeah. Much easier than the previous a few relatively hard questions. Yeah. Just you need some patience. You need some patience. Okay? All right. So organize our data well. Yeah. So with the given information, A1 less than A2 less than A3 in this order. And second array, B1 less than B2 less than B3. Okay? All right. And we also know A2 less than B2. Okay, all right, yeah. Then do elimination. Do the maximum elimination. Yeah. Try your best, yeah. Try to eliminate as many as possible. Many students, they just eliminate some of them, but not all possible elements. Do the maximum elimination. Nations. Okay, all right. Yeah. But when you do elimination, yeah, you need to based on some fact. Okay, all right. Because if we sort these 6 elements after we sort it, yeah, the median. So this is the median. Okay, that is, this median can be interpreted in 2 ways, 2 rows or ways. So that is third smallest or fourth largest. Okay, these 2 rows. You can use these 2 properties to do your elimination. Okay, all right. Yeah, for example, yeah. For example, the first property, okay, yeah. Because it is third smallest. How to use this property to do elimination, right? If you can find more than 2 elements that are smaller than the current element. Then a current, okay? Current cannot be the median, okay? Yeah. I just write short way. Cannot be the median. Sorry. No. Yeah, because it violates this property, third smallest. You find more than 2 elements, right? Yeah, so that's second. Use the second property, fourth largest. Okay, so if you can find more than 3 elements that are greater than the current element, all right? Yeah. Then you can say the current element cannot be the median, all right? Yeah. So you can do elimination, okay? Yeah. Yeah. Just use these 2 properties to examine all the possible elements and see what are the maximum number of elements you can eliminate. All right? Yeah. Yeah. All right, so that's my hints. Yeah. Yeah, but there is one I didn't complete. So that one is probably the hardest among all. Okay. Yeah. So if you just try your best, because I need to give you some very challenging questions. So that is the most challenging question here. Yeah. So if I can find a relatively easy way to explain, so then I will post another video. Okay. Yeah. Otherwise, if I, due to some reason, I couldn't make that video, then you just try your best. Okay. All right. Yeah. That's what I like to explain in this hint part, and there is a possible last video for that question number 23, but not 100%, okay? Not 100%, yeah. But I will try my best, okay? Yeah. All right, so that's it, yeah. If you have your own questions, you can ask me. So before you leave, yeah. Yeah. All right. Yeah.